Okay, so we're going to solve three-dimensional problems, and using the Pythagorean theorem can help us in this section. So let's see, we have a cone with a slant height of 17 centimeters and a base radius of 8 centimeters, and we need to find the height. So what are we given? What do we want to find? We're given the base, we're given the slant height, so let's mark the figure up. There we go. And that's it right there. So okay, you can easily see the right triangle that's formed, so we can use the Pythagorean theorem as the relationship between the question mark and the two sides. So let's go ahead and call question mark h equals, should be h squared equals 17 squared plus 8 squared, get it equal to, it's 289 plus 64, that equals 353, and after we take the square root of that, we get that approximation. Okay? Oopsies, did I? Yep, we gotta take the square root though, so let's fix that. Square root, don't forget. Alright, so I'm jumping to the next problem as well too, so that's the height there. Alright, number 2. Find the length of the longest nail that could fit entirely within a cylindrical can with radius 3 centimeters and 8 centimeters. So if you don't know what the cylinder looks like, here we go. Something like this, of that figure. And the nail is the diagonal. The longest is, yeah, so that's the radius. Let's draw what we know has 3 centimeters, and the height is 8 centimeters. Okay, that's the radius. Okay, the diagonal is from the, that's the longest nail that we could fit in that figure. So we have a right triangle again. So if we're given the radius and the diameter is going to be 6, that's the nail, there's our right triangle, and 6 squared plus 8 squared equals x squared. In this case, the x represents the length of the nail. Alright, now it's just exercise in algebra, and there we go. So the length of that nail is 10. Alright, a couple more examples. Okay, so let's work on problem 4. A cube has sides of length 3 centimeters. Find the length of the diagonal of the cube. So every edge has length 3 centimeters, okay? So that's going to be important there. So let's go ahead and keep moving forward. So that's 3, 3. We want to find out what that length is there, okay? Now that's the trick. If we can find the bottom diagonal that you just see there, then if we know the height as well, then we can find the diagonal that we're looking for. So let's go ahead and do that. Let's go ahead and find that bottom diagonal, the green line right there. So if you realize we have a right triangle, okay, 3 squared plus 3 squared, x squared, that will find the green side. And we're left with 3 square root of 2. So that's what that green side is there. Okay, and what we did was we took this was the triangle that we did. That's the 3, that's the other 3, and we just found that to be 3 square root of 2. Okay, so let's keep going. Alright, so now that we found the green, we know the red, which is 3, and now we know the green is 3 square root of 2. We need to find the blue, and that'll answer us the question. We need to find the blue line, the hypotenuse there. So, as you can tell, this was 3, this is 3 square root of 2. Okay, and we just use the Pythagorean theorem to find that line there. So let's do that. So we got 3 squared plus 3 square root of 2 squared, that's the green line. And that equals, we'll call it z in this case, the blue line, okay? So now it's just exercises in algebra. 9 plus 18 equals x squared. We get 27 equals x squared, so x equals square root of 27, which is 3 square root of 3. And that's that example. We're done. That's the length of the diagonal. The final example I intend to do is number 6, where they talk about a rectangular box with the internal dimensions of 2 centimeters by 3 centimeters by 2 centimeters. So let's go ahead and draw that. So we got the box right here, and it is 2 by 3 by 2. Okay. Let's draw the back. So it is a 3D figure. Okay, and we have to find the diagonal. So we have to find that blue dotted line there. Okay, that connects the corners of the box, the opposite corners. So again, we kind of have to do it like the one of the previous problems. Let's find the diagonal on the bottom. So this diagonal here, if we can find that length, then since we know this side, when we find this side, then we can easily find the hypotenuse. So let's go ahead and do that. So that's the right triangle there. And yes, we'll be able to find the golden triangle in just a moment. So let's find the hypotenuse of the red triangle. 2 squared plus 3 squared equals x squared. X equals square root of 13. So that's the hypotenuse of the red triangle. Now we can find the hypotenuse of the golden triangle, which will answer our question. So we got 2 squared, because that's the height of the box, plus square root of 13 squared equals, we'll call it y. We'll call that piece y there. Okay. We get 4 plus 13, y equals square root of 17. And that is the answer to the question. You can go ahead and find the decimal approximation of it too.